Hello, in this video I'd like to go over some basic Modbus principles and terminology used, with special emphasis on EasyLadder users. We'll go over how to set up the Modbus registers in our EasyLadder software to communicate to a multitude of sensors and controllers. The Modbus Protocol provides a standard that the controllers use for exchanging messages, like a computer language, and it uses a client-server type protocol. The controller requesting the information is referred to as the client. The device supplying the information is referred to as the server. In order for the client to know which device it's communicating to, the serial devices in serial networks are given an ID number between 1 and 247. TCP servers are given an IP address. They are often sometimes referred to as a master or a slave. The master is the same thing as the client, while the slave is the same thing as the server. The master-slave terms originated in the manufacturing industry, while the client-server terms originated in the computer industry. Historically, the difference arose due to how they were applied. Computer terms have, to a large degree, replaced industrial terms, as the industry has adopted more off-the-shelf computer technology. Typically, the client is a PLC or controller, while the server is a field device such as a pump or a valve. With the advent of the computer, automation in factories and warehouses became reliant on more sophisticated electronic controllers over the traditional relays. Dozens of manufacturers began supplying the market with their own automation equipment. It was not uncommon to have several programmable logic controllers or PLC equipment in the same factory, causing integration nightmares for managers and engineers alike. Modbus overcomes this challenge, is free to use, and is supported on most equipment. You have probably seen this type of connector on the back of your computer. It's a DB9 serial connector used in the recommended standard or RS-232 networks. The 232 networks use two wires to transmit data as voltage levels, as ones and zeros, in a point-to-point network. The bits are sent very quickly, typically more than 96 baud or bits per second. An RS-485 network is used to extend the network to multiple devices using the same two bus wires. In order to process this long string of zeros and ones, each individual bit, a 1 or a 0, is grouped into 4 bits called a nibble, and 8 bits called a byte. 2 bytes, or 16 bits, make up a typical Modbus register of 16 bits long. Some controllers may store the bytes or nibbles in different orders, most commonly with the least significant bit first or the most significant bit first. The largest number that can be represented by a register of 16 bits is about 65,000. Of course, we need larger numbers than this sometimes, so 2 registers are used to store larger numbers. The order of the bytes and the bits can be a little bit confusing, but it usually just comes down to checking the settings during setup. You won't need to remember all of these details. The main thing is to have the settings the same on both devices. The data bits are packaged somewhat differently while they travel over TCP IP networks. The main thing to note from a user's point of view is that the slave no longer has a slave ID number, but has an IP address, and can be much larger than the 270 nodes that a serial network supports. The registers are addressed, so when a program is storing data or retrieving data, it is just a matter of knowing which address the value is in. Coils, or output bits, are the lower addresses between 1 and 10,000. To store or to write to these addresses, you will need to use the function code 01. Discrete inputs can only be read from and are stored in the 10,001 range of addresses using function code 2. The holding registers, or address 40,000 through 50,000, can be read from and wrote to using function code 4. This short video would take us through setting up a new project with EasyLadder using Modbus. Here we'll start a new project, and from the Settings tab we'll select the correct target that we're using today. I have the HEC gateway. From the Properties menu we'll select part number from the drop-down menu. Some of the standard devices are automatically added to our project. We will need to add a device to our project, so let's start from the Add Device menu and select the Ethernet. Because of the part number that we selected earlier, some of these settings are already selected for us. We'll also need to add a serial port using UART1 for this example. This is where we set up the communication modes, the data bits, and the baud rate. These default settings will work for us today, but you'll want to match these up to whatever device you're communicating to. Let's add the Modbus Master first. We could use either interface at this point, but let's go with the Ethernet. And we'll put in a 1000 millisecond timeout. And then we'll set up the Modbus slave using our UART1 serial port. Let's give it a slave ID of 1. RTU Modbus is the most prevalent, but you may run across ASCII. Remember to click OK on the way out to save any changes. And we'll set up the communication port last. And here comes the fun part. From this drop-down menu, you can select the function block for the Modbus Master. And again, we'll make sure we're selecting the Ethernet, and we'll select a holding register to read from. So we'll choose the function code 3, and then we'll map our data. Because the holding addresses start at 40,001, it's only necessary to indicate the first address you expect to find the data on the server. We want the value from the register to be stored in an easy ladder variable. So let's add a 32-bit variable with the least significant bit first. And we'll call this variable pressure. As you can see, because this is a 32-bit variable, it occupies 2 registers, address 40,001 and 40,002. The master block still needs to know the IP address of the server on the network, so we store that value here in the variable. For error detection, we need to create an output variable to hold the error code from the function block. You can find the error codes here in the manual under the Help tab. The HEC gateway is now set up as a Modbus Master and will request data from an airline or from a valve bank. Because the HEC gateway is also set up as a Modbus slave, we can store values in the slave registers by inserting a new variable or using an internal variable like our system voltage into an address. Because the system voltage is a real-world input, it can only be read from and it can only be stored in an input register. So that the master can access the information, we'll put it in address 1 of the holding register. The system voltage is now ready to read from a Modbus Master from the HEC controller. This concludes our demonstration of Easy Ladder setup. Next time we'll be talking about our CAN buses and how to set up a CAN network. Happy programming. Hello, in this video I'd like to go over some basic Modbus principles and terminology used, with special emphasis on